everyone. Welcome to Subnetting a Little Bit. Today we will see how a PC uses its subnet mask to determine its network address. We will discuss the following. Overview of a PC sending traffic. The process a PC uses to determine its network address. A quick review of the AND operation. Examples of extracting the network address. In this topology, PC3 is the source, or sending device. When it sends traffic, first it needs to determine its network address. It does this by performing the AND operation between its IP address and its subnet mask. Then it needs to determine if the destination device is in the local network or in a remote network. To do this, it will perform the same operation, but this time between the destination IP address and its subnet mask. The result is the perceived network address of the destination. In step 3, it compares the resulting addresses in steps 1 and 2. If they are the same, it will send traffic directly to the device in the local network. If they are different, it will send traffic to the default gateway, which is typically a router or a layer 3 switch. The default gateway will then forward the traffic. But the primary focus of this episode is to explain how a PC determines its network address. Once again, PC3 is the sending device. Its IP configuration shows the IP address, the subnet mask, and the default gateway. The IP address is 192.168.1.3. These steps summarize the process PC3 will use to determine its network address. In step 1, the host address is converted to binary. This is the IP address of PC3 in binary. In step 2, it identifies the specified subnet mask. This value can be found in the IP configuration. You could also derive it from the prefix length, which is /24. In either case, the subnet mask is 255.255.255.0. In step 3, the subnet mask is converted to binary. Here we see the binary equivalent of the subnet mask. In step 4, the bitwise AND operation is performed. As noted in a previous episode, the AND operation is like multiplying by 1 or 0. This is the truth table for the AND operation. We see it again here using the words host and mask as the input. It takes 2 input bits and returns a value of 1, only if both inputs are 1. Otherwise, the result will return 0. In our case, the PC will perform the AND operation between its host address and its subnet mask. As mentioned, when both input bits are 1, the result is 1. This is the case for the first 2 bits. If at least one of the input bits is 0, the result is 0. This is the case for the next 6 bits. Notice how octet 1, 2, and 3 all have 1s in the subnet mask. This means the original bits in the host address will filter through unchanged. This makes sense because the subnet mask divides an address into 2 parts: the network portion and the host portion. The ones in the subnet mask denote the network portion, and the zeros denote the host portion. Recall the network address has all host bits set to 0. Specifying zeros in the subnet mask for the host portion turns off the host bits, meaning they are set to 0. The resulting value is the network address in binary. In step 5, we convert the result back to decimal. This is the network address. PC3 has successfully extracted, or determined, its network address. Let's consider another example. Here is the IP configuration. The IP address is 172.30.179.102. The subnet mask ends in 224.0. Let's start populating the table. In step 1, the host address is converted to binary. In step 2, we identify the subnet mask. We saw this value in the IP configuration for the PC. In step 3, the subnet mask is converted to binary. This subnet mask corresponds to a prefix length of /19. The prefix length indicates the number of network bits, which agrees with the subnet mask because the first 19 bits identify the network portion. In step 4, the AND operation is performed. Once again, notice where there is a 1 in the subnet mask, the original host bits filter through, unchanged. These are the network bits corresponding to the network portion. The zeros in the subnet mask give 0 as a result. This is the host portion. In step 5, converting the results back to decimal renders the network address in dotted decimal notation. Given the specified host address and subnet mask, this is the network address. Here is another example. At the bit level, it uses the host address as well as the subnet mask to perform the AND operation. The result extracts the network address as noted. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.